So I decided to do a little bit of each proof, even though I said I was only going to do the last few. We'll give it a shot here. So I have the givens written down. Remember, after you write the givens, mark the picture. So AE is congruent to BE. We're going to mark that on the picture. And then DE is congruent to EC. We're going to mark that on the picture. So now I have two sides. Remember, usually you need three congruences, and now I have two. What else do you know about this picture that isn't given? I notice that I have vertical angles here. And I'll just call them angles 1 and 2 because it's easier to refer to them that way. So you're going to say angle 1 is congruent to angle 2 because vertical angles lead to congruence. And now I have three congruences. So if you notice here in a cluster, side, angle, side. So now I'm ready to prove. So I say triangle AED is congruent to triangle BEC because of side, angle, side. Number 6, I have the givens written already, so pause if you haven't written them yet. And then I'm going to mark the picture. So angle D is congruent to angle C, and then DE is congruent to side CE. And again this time, I have what looks to be like vertical angles, 1 and 2. That'll never be given, but it'll be obvious from the picture. So I'm going to say angle 1 is congruent to angle 2 because vertical angles lead to congruence. But this time, I have a different order. I have angle, side, angle. So I'm ready to prove it. Triangle EDA is congruent to triangle ECB because of angle, side, angle, ASA. Number 7, here's your givens. Mark the picture. So it told us that angle 1 was congruent to angle 2. It told us that BA is congruent to BC. What else do I know by looking at this picture? This should jump out at you by now. This is a shared side. So we have BD is in this triangle, and BD is also in this triangle. And obviously they're congruent because they're the same thing. So BD is congruent to BD, and that's the reflexive property when you share a side. Now, what do I have on the picture? Side, angle, side, and a cluster. Side, angle, side. So I write my prove line down. Triangle ABD is congruent to triangle CBD. Why? Because of side, angle, side. Number 8. What did they give me? Angle D is congruent to angle C. I'm going to mark that on my picture. And then CA is congruent to DA. Oh, that's a mistake, sorry. CA is congruent to DA. And just like the first couple that we did, you notice that we have vertical angles with the crisscross here in the middle. Angle 1 and angle 2. So I'm going to say angle 1 is congruent to angle 2. I forgot to write given up here. There we go. Angle 1 is congruent to angle 2 because vertical angles lead to congruence. And I have angle, side, angle. So I have triangle EAD is congruent to triangle BAC because of angle, side, angle. And then I had to do 10 and 11. It's a little bit different. This turns it up a notch or two here. It says T is the midpoint of ME, and it says T is the midpoint of GJ. So if T is the midpoint of ME, then this is the same as this. And if t is the midpoint this way as well, then that's the same as that. We haven't said those are congruent yet, so now I'm going to say it. That was given. That was given. But now I'm going to say that this is congruent to this. GT and JT. GT is congruent to JT because a midpoint leads to two congruent segments. But also, this way, since it was a midpoint in both directions, then MT is congruent to ET for the exact same reason. A midpoint leads to two congruent segments. I still only have two congruences, but just like 4 problems that we did a minute ago, I have another pair of vertical angles. So I can add 1 and 2 to the mix. Angle 1 is congruent to angle 2. Vertical angles leads to congruence. And now I have strike 3. Let's see what we have on our picture here. Side, angle, side, right in a cluster like that. Side, angle, side. So I write this down here. Triangle MGT is congruent to triangle EJT because of side, angle, side. And the last one, we have bisectors. So I have BD bisects ADC, and BD bisects ABC. There we go. Both of those are given. What does that really mean? BD bisects the angle at ADC. This is ADC. So if this is bisecting, that means that this angle and this angle are the same. And if you want to, you can just call those 1 and 2. But it also says that BD bisects angle ABC. So it's saying that the same BD bisects the top angle as well. So that means that these two angles are the same. And if you want to, call them 3 and 4. So then I'm going to put angle 1 is congruent to angle 2 because an angle bisector leads to two congruent angles. But also, at the top, angles 3 and angle 4 are congruent for the exact same reason. An angle bisector leads to two congruent angles. So that gives me 2 congruences. I'm looking for a third. And if you notice here, they share this wall in the middle. So BD, BD, reflexive. So BD is congruent to BD because of the reflexive property. That's my third congruence. So now I'm ready to say that the triangles are congruent. This time it's because of angle, side, angle, and a cluster right there. Angle, side, angle.